Hello, everybody. What is this?
Hey, we're here at Show and Tell. We're here at the Adafruit Factory. It's me, Lady Ada, with me, Mr. Lady Ada, but this is your time to shine. Show us your project, what you're working on. Give us a quick update. Today is speed round night. We have to get out of here at 7:45 for a very special show. So please, just give us a quick update on what you're working on.
You have 2 minutes to dazzle the world.
Yes, let's start off with Noah and Pedro.
All right, we got a quick one. So the feather box was a project we did a couple of weeks ago. This week we updated it for the TFT feather wing. I even made this little kind of Vista mount adapter thing for tripods, so you can mount this to Vista mounts or a regular tripod. So great way to kind of get a screen for your feather projects. Check
Like it.
Hey, how you doing?
Cool.
Okay.
Nice.
That's it. Thanks, guys.
And then
All right.
Sophie, big old sword.
Oh, big sword. That's work in
Something on your
progress.
Instagram.
Big old sword.
We will show the video of one of those and the time lapse on Ask an Engineer tonight.
Awesome.
All right,
Thank you.
nice sneak peek.
Thank you. Tony D, what you got cooking?
Hey, yeah, so just a quick little mention. I did a video last week on using the Jupyter project with MicroPython. So Jupyter is this really cool web-based notebook and actually other kinds of notebooks. It's a way to write Python code in your browser and have it run normally on your computer to do like data analysis and stuff. But I showed how to make a real simple little kernel that lets you connect to a MicroPython board like the ESP8266. So you can, in your browser, write Python code that gets sent to the board, executed, and then you see the results back in the web page. So a really cool thing. It's just kind of experimenting around with some of the different tools and hopefully to see how the MicroPython kind of editing world evolves so that you get more editors and stuff like that. So interesting thing maybe to play with and try out.
Outstanding. And Carol, who's part of the Jupyter project, is going to be stopping by Adafruit, so great timing.
Cool, yeah, exactly. Jupyter is a great project, so well worth checking out.
Okay.
Totally. Okay, next up, Sabrina, we're going to go to you. Unmute your mic and show us your project. Hello, Sabrina. How are you?
Hey, Sabrina.
Hello. I didn't think I'd go first.
Oh, you're special.
Yep. We're starting with people named
Cool.
Sabrina tonight.
Hello. Okay. Well, my project is a Braille translator. The idea is going to be where we take a camera and use the live feed through the camera to translate the written text into Braille. But as of now, we're having complications using the Arduino with the camera. So for right now, we're just using the keyboard and clicking a letter on the keyboard and using that to translate into Braille. Sorry. But the project right now is using LEDs instead of solenoids, which would push up and down for the pins. And we as in my group and I, we made the circuit so it's hardwired right now for LEDs, but you can switch out the LEDs and then switch them with solenoids to use them like that. So I have a simulation online that I can show you.
Yeah.
And it'll be like show you how the code works and everything, and yeah.
Give us a quick preview, and then you can always come back and show us
Share it
more.
up.
Trying to get screen share going. Yeah, you can see me. See the screen, I mean. So this is the project right now. And here's the code down here. Once I get it started, monitor, and I'll type in a letter and these will light up in order. Like if I click the L button, these three right here should all turn on at once.
Okay.
So it'd be L in Braille.
Yes.
Very cool. And you're using the Autodesk simulator, so you can try this stuff online before you put it on hardware.
Yeah.
That's very cool. We don't have a Braille badge. We should do a Braille badge.
We should do an assistive technology badge.
Yeah.
Yeah. All sorts of projects.
My friend Rebecca showed me the site as well as what?
Oh, yeah.
You're not. Sorry,
wasn't
my
cheating.
friend Rebecca tried to get on the camera and like.
Only
Transported,
one person at a time.
transported across the country.
Come on, serial monitor.
Okay. We see it.
Yeah, it's not loading the serial monitor.
All good. All right, do you want to
Like
come back?
you can see the Arduino right here is plugged in, but the serial monitor is not showing up.
This is the problem with serial.
Okay, well,
Well, why don't you come back when you put it on hardware? You get a show and tell sticker tonight no matter what, but you could get potentially
Okay.
2. All right, thank you so
I
much,
just like
Sabrina.
seeing the simulator.
And thanks for working on this. This is one of the cool things. AT Makers is one of the folks who comes on our site, and a lot of people are doing assistive technology for makers, so thank you so much.
yeah, of course. I only heard about this because my friend told me about it, and I was like, hey, why not? Give it a shot.
Speaking of,
Speaking of your friend,
next up, Rebecca.
You sound off?
You're good.
Sorry, we're in the same room and I don't want feedback. Sabrina, stop laughing.
The feedback was too much.
So I've been working on adventures in 3D printing, some things, and my mistakes include making things smaller and less quality to make them print faster, because I'm impatient. So this is a really bad thing that I tried to print, because I figured out how to print logos, and I tried to print the school's logo, and that didn't work out so well. But I also learned this week that long prints while I'm not there don't always work out because I don't have a spool holder yet. So this is a bottom of an octopus, because the print failed and died and had issues turning the spool when I was in class. So lessons are don't go to class, instead print stuff, or get a spool holder, which I will get this weekend. Yeah, that's a long print, and my issue right now is long prints because I don't have a spool holder. The other thing that I've been doing is I've been doing community outreach with Society of Women Engineers, and we went to a middle school with bobots that we were jousting with balloons, and we had extra time at the end, so the girls were made their own joust designs, and I'm gonna 3D print models. But this is like a basic little robot model that I made in Tinkercad. But this wheel, which is actually like the back wheel, broke off in printing because it wasn't connected very well. So I'm gonna edit the design and then add their jousts and print them out for them next week.
sounds good.
Very cool. Well, as always, you get an As Seen on the Show and Tell sticker, and if you want a 3D printing badge, just let support know, and we will send you a 3D printing badge as well.
Okay.
All right.
Awesome, thank you.
Yeah, all good. Next up, Zach. Hey, Zach, how's it going? Unmute your mic and show us your project. If everyone can keep it to like minute and a half, we can get through everyone and still have a show after.
That's right.
Hi, Lady A.
Hey, Zach.
So I'll show you what I made here. My grandmother had a time system for a church. It was built in the 60s. It's really just a 8-deck tape or 8-track tape player that played 2 minutes on a loop. And so I used a Raspberry Pi to build a kind of modern system for it. It's written in Node.js and has a web browser, web kiosk running on the Raspberry Pi here, in a nice little 7-inch touchscreen for them. But the project that I made kind of as a pet project for her is related to that. Is I took that because I wrote it in Node on a Raspberry Pi. I went ahead and put it on a Pi Zero, and just as I was thinking about making it tiny and putting it in a model of their church, Lady Ada, you introduced the speaker bonnet, I think, at the end of last year, and so it was perfect because it added audio, added an amp, and we'll play chimes for her. And
Oh, that's so cool.
That's so cool.
I have speaker up here, nice little $1.95 speaker from Adafruit, and then speaker bonnet, and so my grandma can hear her. You don't have to listen to that over and over again, but chimes at home. So she has a replica of her church steeple with stained glass that light up, and she can basically be at her church whenever she's not there.
Outstanding
You're
project.
a
Zach.
great grandson.
All right,
man.
well, you get a Seen on This Show and Tell sticker. You can put it somewhere there. One of the things that I always wanted to see was more replicas of churches because they're beautiful. They have stained glass. They make sounds. They're all individual. So this is really neat. Thank you so much for sharing
I
that
love
project.
it. All right.
Good.
I'm not
All right.
going to make you share the cookies she's going to make you with me, but I wish I could.
All right. Next up. Hey, Paul, how's it going? Paul, unmute your mic and show us your project.
Hi.
Hey, Paul.
So basically, I wanted to learn machine language, and gosh, because it's such a useful thing. So all the CPU emulators that I came across were like wanting in terms of debug output and stuff like that. And I was really not interested in spending thousands of dollars on hardware. So instead what I did was I wrote a Z80 CPU emulator in Python.
Right.
And so I can give you, are you seeing my screen?
Yeah.
Yeah.
Awesome. Okay. So let me hide this because
Hi, us.
yeah.
We're in Python.
So on the right side is the debug output from the CPU emulator itself. On the left-hand side is the terminal or the console, which is running via Telnet. So if I just go over here and hit that, it's going to load a machine language monitor that I wrote into the first 8K of RAM, and when it's done, it's going to show me a ready prompt, and then I can do fun things like do a page dump of, well, let's see what we loaded from ROM. Let's see, 0100. So this is the second 256 bytes in RAM, and on the right you can see like the OCWA lines. In the debug output, that's the opcode with argument. So those are all Z80 instructions. You can see the register status. I have the debug turned way down, so you're not getting all of the noise from like, I just put this on the bus, I just took this off the bus, and all that other kind of crazy stuff. Checking flag statuses and all that. But basically, you can do inspects and deposits like you can on a, an Altair or this is the command list that's available. So like, for instance, if you wanted to change the prompt from ready to something else, you could do like a deposit 01 D1, D1 to let's say 54, and now it's TD, which is, I guess that's if you're a Java. And you could do D01 D3 44, and now it's Teddy. And there's a, let's see, was it 2000? So there's a bootloader program that loads on initialization into the bottom of the second 8K of RAM that loads the CPU or the machine language monitor from ROM, which is all the way up at the top of memory, down into the first 8K. So if we run this program from the monitor, 2000, then what it's going to do is it's going to basically reduplicate that thing. It's going to load everything down from ROM into RAM and run it, and you should see the prompt change back to ready. So
Outstanding.
Nice.
Thank you so much, Paul. This was a good project. Don't listen to anyone about not learning machine language. There is reason to do it, mostly to show it on the show and tell.
This is cool.
So when you email support@adafruit.com, we have a hello world or reverse engineer.
We have a hello world sticker. That
Yeah,
would match. It's got
you should
green
do that
text on black.
Okay.
all right, great, thanks. I just want to figure out how to unshare my screen now.
Okay.
Nope, it's permanent. Okay, next, Michael, unmute your mic and show us your project. If everyone can keep it to a minute, we got a speed round.
Hi.
Go, Michael, go.
All right, so I'm going to show you guys this little board that I made. I designed for the BeagleBoard org guys. You might have seen it on Hackaday. Here's the Altoids tin, right? The little
All right.
guy.
Yep.
What's in it?
I can get it out of here. And inside is the mini BeagleBone if I can get it out of the tin. It's kind of tricky once you get it in there.
Yeah, because of the lip, it's challenging.
And it's not fun, especially when you only get a minute. Well, here, I'll just show you from the inside of the tin. So there's the board inside of the box there, and it's just a mini BeagleBone compatible. It's not completely compatible. It doesn't have all the headers and whatnot, but I designed this in KiCad as a reference design for the community, and tonight I'm actually gonna assemble a few by hand. So that's going to be fun. This was actually made by Circuit Hub, kind of like a turnkey.
Oh, cool.
So that's the guy, and it runs the same Debian distro that all the other BeagleBoard products run, and worked first try, no wire mods. So I was very proud of it, and it's just an SD card and 2 USBs, power and reset, some LEDs, and a nice little expansion header. If you want to learn more about it, I have a Hackaday IO page. It's called the Pocket Bone. It's just a little guy, and I'll have some videos of the assembly process after I'm done tonight.
Yeah, and come back next week.
So that's about it.
Okay, email support@adafruit.com. There's plenty of room for an As-Seen on the show and tell sticker, and let them know that you should get a BeagleBone badge, because we actually have those.
All right, cool.
It's as small as that.
Okay,
Alfredson.
we're going to go to Adam, and then we're going to wrap up with C. Scott. Show us your electron microscope.
Hey there. So, big news this week. It's working-ish. The high vacuum system is fixed, except during the middle of the show and tell, my water chiller froze solid, and the
Mine did too.
Overheated. So I just did a 5-minute emergency repair on that, so it's still running. But I just want to show you a couple of pictures because this was pretty funny. To do leak, can you guys see my screen?
Yeah, we'll wait a second. Yep.
Yeah, so to do leak detection, I ended up not using hydrogen or helium. I used soap. So I sprayed my entire microscope down in a whole bunch of soapy water, which seems like a bad idea for electronics, and it is. But after I sprayed it with soap, I pressurized the whole column. To do that, I had to latch down the top of my column with a ratchet strap. And then I built an adapter to go from my air compressor to the microscope column. Pressurized it up to about 20 psi. And then once I did that, any leaks showed up as large bubbles of soap. So I found one giant leak on my bleed valve. Got that patched up. I still didn't pull down. So I actually tested my pump. And it turns out that my pump casing was really leaky. So I had to take apart my pump. And then I put Loctite 515 on that piece, got it sealed up, and I got my vacuum down all the way into the operate zone, which is currently where it's sitting now. So big week. Oh, and shout out, you guys have the DS1054Z, let's see, stop screen sharing. You guys have the DS1054Z oscilloscope. Amazing for debugging this microscope. It's proved very useful. So I've got it set up to monitor vacuum levels right now, so I'm able to, when I make any change, I can very precisely track any changes I've made. So that's the progress this week. Everything's kind of working and held together by a little bit of duct tape. So
nice.
Okay, well, we'll see you next week. Please come back. And this has been a long time in the making. Congratulations.
This is so exciting.
I haven't actually turned the scanning system on yet, but it can be turned on as soon as I install my photo multiplier tube, which is maybe a whole new challenge, but about probably halfway there now. So
you're doing great.
All right. C. Scott, play us out.
Okay, can you hear me this week?
Yep.
Great. I haven't been on lately because I got 2 bouts of the flu, and it kind of kept me offline for a while. Anyway, I managed to get some work done. I've finished the hyperbolic tangent. This is my mixer with the soft clipping. Next week I'll have it installed and running in the cabinet so you can actually hear what it does. But it's an audio mixer, but it overdrives in a pleasant way instead of harsh crackling clipping noise. I'm almost got this built. This is the string tone generator. This is the one that has the feather, the SAMD 21 feather on the back is the compute engine. And when I have it built and running, I'll have more to say about it. It has a little OLED screen on it and a few knobs and whatnot, mainly for me to debug the engine. But as you may recall, I had a little bit of an exposition on this guy. This is the Melody, and it had issues here. And I've done a few other things since my little article that I blogged about, where I made sure I had a certain width of copper to the main power and ground returns. You know, so there's no longer any thermals here. Now, it takes a good bit of heat. Now, this is where a selective soldering machine is ideal, because it has 200 pounds of molten solder to back up the soldering of the individual points. But this hole and this hole, this hole and this hole, this hole and this hole, these allow you to use QC connectors on the critical inputs. And for those folks who don't know what a QC connector is, here's one of my set point controllers. These metal tabs on the end, these are rated for 25 amps. And what you do, you crimp the socket part onto your power wires, and you plug those down, and they're cinched in place. They're a much more positive connection than the screw terminals that are currently being used. And I have this board in the soup right now. When it comes back and I have it built up and working, I'll give you a walkthrough of what else I've done to it.
Yes.
But
Outstanding.
that's what I've been doing.
Good.
All right.
All right,
Well,
glad you're better.
Third time's a charm with the fuel. Thank you, Zach. Thank you, Tony. Thank you, Sabrina. Thank you, Rebecca. Thank you, Paul. Thank you, Pedro. Thank you, Michael. Thank you, Scott. And thank you, Adam. We'll see everybody on Ask an Engineer in just a few minutes.
Phil, I have a box. I finally have the CroBX boxed up to send you guys.
Okay.
But
What's
that's
in
it.
the box? What's in the box? Okay. All
CroBX.
right. Thank you so much, everyone. This is our favorite 26 minutes this week. We'll see everybody on Show and Tell next week, 7:30 p.m. Eastern Time, and we'll be on Ask an Engineer in just. All right.
Thank you, everybody.
Thanks, everybody. Woo. All right, we did it.